So here we are. We're on to chapter 5, which is IDA Pro, and this is the thing which I put off, so the chapter's a bit out of order, because like I say, this tool is hard to use. So let's talk about it, and you'll have a project where you use it a little bit to learn the basics of it. But this is the tool that scares everybody. IDA, the full version of IDA, which can debug 64-bit code and iOS code and everything, and disassemble code back into readable source code, costs like $6,000. But there's a free version, which is, of course, the older version, the freeware version, and you can use it for, I think, only 32-bit code and only x86 code. But it's good enough to do some and learn how it works. So yeah, there's the full version, pay version. Here's the old version, 32-bit code only. All right. So when you open IDA Pro, you open a program in IDA Pro. To look at it, you'll see the program in one of two modes. This mode here is the most famous mode. You see a block of code with some assembly language instructions and then arrows pointing to other blocks of code. This is the way a lot of people like to look at it. The other way is the way I'm used to it from the really old days, like line printers, just this stuff, just page after page of unreadable code. And this is why everybody hates it and says, oh, this is terrible. Like a virus would be like 1,000 pages of this. And you say, man, this is horrible. I'm never going to figure that out. And I thought this was the only way to analyze malware. That's why I named this class Practical Malware Analysis, and that's also why they named the book that, because this was impractical malware analysis, when all you could do was read this and figure it out. That's not easy. Now, there are some people so good they can do it, and I am teaching assembly language programming now at another college. If you learn assembly language, you can read this stuff more or less, but it's very painful. So this is not but first you try easy things, like strings and dynamic analysis. And then you go to disassembling it only when you have to. So, but that's the idea. You see the raw assembly codes here that makes it. So the default graph mode display shows up here. Now, down here's the actual commands: push, EBP, move, call a subroutine here, which is probably going to start the program, and then on you go, jump if, compare something, jump if it's not 0. These are all the commands. And up here you have some input variables, the parameters, I think, where it just gives them names. And then you have some, and these are comments automatically generated by IDA Pro to hopefully explain to you what's going on here. This is the main function with incoming parameters. This is the default mode. Now, a lot of things are missing from here, like the address is missing. I can't even see the address of the code, and the raw bytes are missing, so you typically want to turn those on. So you go in and turn on line prefixes and turn the opcode bytes up to 6 or something. And now you'll get a more informative view. Now it shows you the address of every command. Here's the raw hexadecimal machine code, and here's the assembly language. And now you can tell this stuff here all has the same address and no real bytes. This is all automatically generated comments to try to help you understand it. This is not real assembly code. This is the assembly code. So this is normally what you want to do, adjust your graph mode to that view so you can see what's going on better. And so there's these arrows connecting these blocks. So red means red and green come out of an if statement. And if the condition is taken, then you go the green way. Like if the condition is true, you go the green way. If it's false, you go the red way. And blue is an unconditional jump, which means you jump from one block of code to another block of code, but there's not an if statement involved. And if you have an up arrow, then you have a loop that's going back and repeating some previous commands. So here you can see, here it does a compare something and then a jump not 0, so that's an if statement. So it has a red path if the condition is false and a green path if the condition is true. And so it'll go to either here or there. Then after those, these blocks both jump to this location with these blue arrows, which are unconditional jumps. There is no if statement. They always go down here. So that's what the arrows mean. Then there's highlighting. If you highlight text in graph mode, it'll highlight every instance of that text. So this can help you. You're trying to figure out what this is. You can, like EBP plus var4, what's that? You can see all the places it's used. That's a handy technique. And so here's what text mode looks like. Here you have these arrows, which indicate you're jumping down, because this is doing a jump to some other place. So the arrow shows you where it's going. Here you have the section. Remember we talked about there's the text section, the data section, the R data section, and the assembly code is always in the text section. So we're in the text section. Here's the address. And over here you have the marking a location of the address, and here you have the code. And once again, the actual code starts here at 122B and then 30 and 35 are these commands, and this 2 B or 2.8 is 2B. 2B is repeated up here because these are just comments automatically generated. These are not actually assembly code instructions. So it's trying to help you by making it easier, but it's not too easy. And here's another comment. If you refer to a string, it'll put it here in gray. So that's pretty handy. Just like we saw, Ollie Debug will do this. On the right side of the screen, it will try to put readable stuff, like messages in English and things like that. And so you're typically looking at the right is where you can find easy stuff to get oriented, where you don't have to like dig through this dense assembly code right away. You can get some idea what's going on by looking at the right. Now you can turn on automatic comments, you can turn them on or off, and that'll determine whether, if you turn them on, it'll put comments in every instruction, which are not terribly useful. Call, procedure, add, logical, exclusive, or. I think you don't really need that. We know what call, add, and XOR mean. Yeah, did it finally come up? Oh, good, okay, good, glad to hear it. All right, anyway, so, all right. So then there's other windows. There are a lot of other windows in IDA Pro, just like there are a lot of other windows in Ollie Debug. We used the main CPU window and the memory window and some other windows. So here you've got a window just for functions. This will show you each function, the start and length of it, and then some flags showing you things like whether it's a library function or not. And you can sort. So you can sort for the size of the function. The large function might be more important depending on your circumstances. There's a names window, which is kind of handy, where it just has named objects, like main is where the program starts. For some reason, a lot of code also uses a start location too, and I think it goes to start to set something up and then jumps to main or something. Uses both of these when starting. And there's other things here like the names, this is the name of an object or a method. So this might help, looking at named code, named data, strings. And then you have strings, of course, just like we found with bin text. It shows you the strings here, it shows you where that string was found. So this is pretty handy. The great thing about strings is they're easy to understand. You don't need to read any dense stuff. You see the name of a library, the name of an API call, or a message that's going to be printed out. So that's where I often start is strings. Then I can find some part of code I can understand, like where it prints a message. Then you have imports and exports, just like other things we'd say. This is a executable program, so it has a lot of imports. It uses library functions, but it only has one export, which is start. The only way in is to start where you're supposed to start it. It does not let you start anywhere else. All right, so you can view data structures here. And then if you hover over one, it'll show you the structure. If you've done C++ programming and get used to these things, this structure has a whole bunch of records. If you get deeply into the Windows API, you have to worry about the structures. But for most of what you're doing, you don't have to dig into it that deep. And then you can cross-reference things. If you double-click a function, it will jump to the code in other view. And this is true of almost anywhere in IDA Pro. If you double-click anything, it will show you another view of that location or object. Hey, what's up?
Happen to have a network RJ45 tester inline?
No, I don't.
I have not had one of those since I taught networking 20 years ago. So
Yeah.
the answer is,
Yeah,
we have one somewhere.
I've never used them. I just heard about them, but I never taught the hardware class.
You plug in these little LEDs and flashes.
Yeah, yeah. I always just grab another cable. Yeah, it's my solution. Yeah.
One of my students has asked.
Yeah. Good luck. Yeah. Anyway, all right. So if you double click it here, it'll show you another view of that same information, like in hex. And so one thing I mentioned before, and it's good to see, this is what a function call looks like. So I'm going to call this function to find out the string length of something. There's some extra folds there. I don't know what this imp w@4 stuff is, but this gives some kind of measure of a string length. So the way you call a function is you move something, you get some data, push it on the stack, then you get more data and push it on the stack, then you call the function. This is why in the other class we talked about format string vulnerabilities, but this is what a function call looks like in assembly code. You push the parameters on the stack, then you call the function. Now, the one thing that's funny about this is if you forget to put the parameters on the stack, the function will still run because it runs and it just looks on the stack and whatever it finds there, it uses it. It doesn't know that you didn't load it properly. And this is what leads to a thing called the format string vulnerability. In C, you can print a variable without including the format string. And the print function will just take whatever it finds on there and interpret it. If you feed it a format string, it'll print whatever comes after it, thinking that's the variable. So you can get it to reveal memory that the developer did not intend for you to see. and you can even take over the box with it. But anyway, this is how function calls look. You push data on the stack, then you call the function, and the function expects to find the parameters on the stack, and it has no way to know whether you really put the right stuff up there or not. All right, so often when you get in these programs, you get, it's easy to get lost. And so there's ways to reset the desktop to get back to the default view if you're wandered somewhere and you're lost. And you can also save desktop where you like where you are. And people, a student I had that found the new jailbreak of iOS, the first new one in 7 years, took this course, there was other courses. He learned about IDA Pro. He said, this is awesome. I went and spent $5,000, $6,000 to get the professional version of IDA Pro and spent like a month with big monitors going through the bootloader of the iPhone until he found a bug. So you can do it, but it's a big research project. You go through it and you label things and you take notes and you save the notes and save the version and you slowly figure out what it all means. It can be done, but it's not that different than like a cop tracking down who killed somebody, gathering all the evidence, putting together all these pieces and pictures and arrows and everything. So you can double click any entry here to display it in a disassembly window. So you find a string like heap alloc, and if you double click it, it will take you to where heap alloc is used. So here's the storage of that string heap alloc. It's going to be referred to somewhere. And, all right. And so if you double click any address in the disassembly window, then you'll go to that location. So if you're looking at the disassembly and are going to call something, I could double click this and it will show me the code at that location. And you have forward and back buttons like a web browser. So you can go back to where you were, which you often have to do because it's easy to get lost and find yourself somewhere crazy. This is something I didn't know about for years. It's really cool. The navigation band is up here. This is a summary of your entire program. And light blue is library code. Dark blue is the user-written code. That's what you want. Red is compiler-generated code. So if you're lost somewhere in like stored data or the Windows API call or something bizarre, the light blue is the stuff you want normally because you're trying to analyze the code written by the developer of the malware. You don't want to analyze code written by Microsoft. That's not really productive. That stuff is not malicious, and it probably doesn't have any bugs you can find. So when you get lost, you just can go back to this navigation band and go back to the dark blue stuff. That's the stuff that contains the actual code written by the malware author, which is usually what you want to analyze. And you can jump to any location if you know the address, of course, and we've done that in Ollie debug, and it's the same here. You can search for many things. Next immediate value, next sequence of bytes, next void, all sort of things. Lots of search. Search text is usually what I use. To search for some printable text like a message. And then you've got cross-references. So if you, there's code xref comment. This means here it is defining a function, main, and the cross-reference will show you where this main comes from. Main is called somewhere, so if you hover over this, it'll show you the code. Here it is calling main from somewhere else. And if you double-click it, it will go to the place where it's called from. So this is how you can help find yourself around, find navigate through things. If you press X, if you highlight it and press X, it'll show you all the locations. Now there's only one cross-reference to main, like say main comes from start or something, but another function might have many calls to it. And you'll see this when we do the IDA Pro project. All right, then you can analyze functions. It identifies a function and it names the local variables. So here, notice all these, here's the actual function, move, push, move, push. Here's the comments it made. So it noticed this function has, it gives the function a name, sub 40140. Since it doesn't know the name of the function, it just gives it a name from the address. And then it found there were 3 variables, a pointer, they're all pointers, and he just calls them arg0, arg4, and arg8. So it assigns these names, and when you're analyzing a program, you'll figure out, oh, this is the IP address. So you can rename it IP address, and it'll name it whatever. This is like the input string from the user or something. If you figure out what things are, you label them, and it will then propagate that label through everything, and you can gradually put it together like doing a jigsaw puzzle, gradually figure out what little pieces are, and it takes a long time. We're not going to do all that in the projects in this class, but that's what you do. And then there are graphing options. I've never gotten any good out of these graph things, but you can see them. There's 5 kinds of graph. These are legacy graphs. The first 2, flowchart and function calls, seem completely pointless. Xrefs 2 are slightly interesting, although I didn't get much good. I took calc.exe, the Windows calculator, and I looked at, I just made a flowchart, cross-references to it, and I found something called check Windows genuine status, which is pretty interesting. This means apparently Microsoft intended to check your activation of your Windows and refuse to let you run calculator if you hadn't activated your Windows. But I don't think they ever implemented that, but it's in the code, that function. Around the time of XP, Microsoft made a big deal about caring whether you actually had a pirate copy or a legal copy of Windows, and they fouled it up so badly that they added something to Windows Vista that would check every 30 days to make sure you were legal, and then they didn't keep their activation server up. So a whole bunch of legal Windows in corporations went down for like 3 days because Microsoft activation server was down. So that embarrassed them so much that they took the activation out of Windows and they never had the guts to put it back. So now it never does just shut down and say you have a pirate copy. It just like turns the background black or shuts down every hour or something, but they don't have the guts to actually turn it off because it doesn't pass activation because they can't figure out how to keep their activation server running. Anyway, here's what these graphs look like. You get these graphs like this, showing cross-references from one module to another. Like I say, I've never got much good out of them. You can customize them too, but I haven't found it very useful. All right, and so you can change things. You can rename locations. Like I say, if you have a name like sub 401,000, you can give it a name that means something like reverse backdoor thread. If you change it in one place, IDA will change it everywhere it appears. So as you gradually figure out what's going on, the thing will become more and more readable, unless you're sloppy and you give it the wrong name, and then you'll just be confusing yourself and digging yourself into a hole. And so here's an example. Without renamed arguments, you have code here, but after you read it, here's something called arg4 and something called var598. Well, they figured out that arg4 is the port string, and this is the port number, so now you can see a little bit more what's going on here. That's what you do. You rename these things, and it gives your descriptive name to them, which that's how you'll gradually make this more readable. You can add comments with colon or semicolon. And it will show all the arguments in hexadecimal, but if you right-click, you can see it. So this is a 1320, when it says hex, that's 4896 in base 10. Here, I show it to you in base 8 and base 2. I don't know why anybody would want base 8 anymore. I used that 40 years ago. I mean, there was once a time when we used octal. Anyway, it's there, but I don't think anybody's willingly using octal anymore. We're all using base 10 or base 16, or base 2. Anyway, but it's there in case you like octal. And you can have named constants. Symbolic constants are here. The names of things, a lot of these are part of the Windows API. And so that makes API arguments. So before symbolic constants, you have garbage like this. After symbolic, instead, here you're pushing 80, but in context, this is file attribute normal, because you're doing something like creating a file, and there are parameters, the attributes, there's a value, and the file attribute normal is the name of this value, open existing is the name of that value, file share read is the share mode, equal to 1. So these are the more descriptive names of these arguments, and that's what you'll find if you read the Windows API manual online. This is what they name all the options. And you can add plugins to IDA, just like you can to Ollie. There's a scripting language, and you can have Python scripts. You can add lots of things to it, like find format string vulnerabilities I was talking about, decrypt data, and so on. There you can have all kinds of scripts added to enhance the functionality of your IDA. I've never used anything but very simple activities in the plain IDA, but it's an option. So let's try a Kahoot about this stuff, which is chapter 5, right? Yeah. There it is. What's that? How many have to use what? Oh, well, less than 1 gig. Oh, I'm surprised. Okay, I thought 2 would work, but okay. I'm glad you found a solution. Yeah. Yeah, yeah. Good. Use one of these? Yeah, do whatever you like. Yeah. I can do, yeah. All right. Sure. Yeah, I'm not very formal. Yeah. Yeah, that's good. Yeah. Sure, yeah, that's right. Yeah. Well, it's because I'm teaching adults, you know. I'm not here to treat people like children. Well, I may not have enough contestants today. We'll do it anyway so people can see the questions to review, but there's not much competition if we don't even have 4 players. We will charge ahead. Hacker Kitty, the few, the proud. All right, so which feature shows the instructions in boxes connected by arrows? Yep, that's graph mode. Ah, somebody else came. That's good. Okay, that's graph mode. All right. Good. All right, which one shows user-written code as dark blue lines? That's the navigation band. The dark blue stuff is the stuff written by the developer of this software, which is usually what you want to be analyzing. All right, what kind of code cannot be disassembled by the free version of IDA Pro? 64-bit is the code you cannot analyze. Visual Basic compiles to the same kind of executable code. So it can do that 32-bit code and it can do DILs, but it can't do 64-bit code because you're using an old version before 64-bit code was common. All right, how do you switch from graph mode to text mode? That's what the spacebar does, not F1. All right. And how do you move to a specific hexadecimal address? That's G to go there. All right. So anyway, I'll make a note of the winners, Baroque, and Hacker Kitty. And so there is an IDA Pro project where you practice this stuff, but I don't plan to demonstrate it tonight. That might be best, but I want to talk about the DILs instead. I think that's more important. I'll just mention there is a section here, disassembly. Here's where you do some basic stuff in IDA Pro, and this will come later in the class. But if you want to use IDA Pro right away, that's the project to do, where you practice these simple operations to hunt through a little bit of malware there. But I'm going to stop this, and then we'll try looking at DILs instead. It's a more important thing to show you tonight.